Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video today is going to look at the adapter classes, the stack and the queue in C++, of course. And let's get right to it. You already know the problem. And so I'm going to develop my own C++ stack class. And I stole everything from the Blackboard problem, and I just kind of moved it into the header for my stack class. So the goal right now is to say all I have access to is a double-ended queue, the deck, how it is pronounced, and I'm basically going to adapt a deck to behave like a stack, using object-oriented programming, and I'm just going to basically allow the functionality and modify and adapt the functionality of the deck under, basically under the hood, under my code, so that you would never truly know that that's what is going on, that the stack is using a deck. And that's what really happens also in the true stack and queue classes here in the standard template library. It's adapter. And what's part of the templating of the stack class and the queue class is that under the hood I can use a deck, I could use a vector, I can change what is used under the hood, but we're not that fancy. We're not going to get to that kind of stuff right here. So we have our stack. We want a default constructor, copy assignment operator, and then the others, the empty function, pop, push, size, swap, top, and again, it's all going to use a deck under the hood. The first thing I am going to go about doing is getting all of this and moving this over and defining these guys over in the CPP file. And all of that, why not? Failed for one of the 9 functions. This one, why is that? That's interesting. Interesting. That's okay. We can write it ourselves. I haven't really seen that pop up too much. Wait a minute. Where did it go? Where'd everything go? Let me see about deleting this, bringing this back, bringing everybody back. Hey, whatever. We'll get it working. That is very, very strange. Let's go under the hood here. Let's see what's happening. That exists. Stack. No, there's nothing really wrong here, so I don't know. Oh boy, I don't want to have to write it all myself. But anyway, so let's see. Let me try it one more time. Nope. That's weird. Isn't that weird? I think it's weird. Where does this actually go? It says it's defined, so where is it actually? Okay, let's go to definition. No, none of this is defined. Oh well, we'll go back to the old days. Okay, so let me drag this over so we can do these one at a time. Okay, so the default stack constructor takes no parameters, does nothing in the body. And I like to do this just because I'm me and I like to be very explicit, especially when I'm coding things like this, especially teaching you guys stuff, is that you have a contract to make sure that every member variable is initialized when you end a specific constructor. And so in this case, I'm just stating that I am going to set up D, which is my double-ended queue of type double, and it's going to be constructed using their default constructor. And so you don't necessarily need this, but again, as a teaching tool, I like to do that. So you get to see that the D member variable gets initialized. Okay, so now this guy, the copy constructor. And again, it's a constructor, so it should always use a initializer list, and my D is going to be a copy of the D from the other one. There you go. There's your copy constructor. There we go. So I'm going to take the double-ended queue and copy it all into my double-ended queue, and that's the end of the day there. Okay, so now this is a little more complicated, but it's only slightly more complicated. Okay, so what's going on here is I'm basically, the copy constructor and the copy assignment operator are basically going to do the same thing, but just do things slightly differently because of the way that the object is created in memory at that current time. So my goal here is to say my D is just like before, is equal to the other D. So my D gets modified, but this one does not. That's why I'm allowed a const reference here. And so once I do that, I need to return something. I mean, I need to return star this. And whenever you're dealing with equals, plus equals, minus equals, things that are changing this, like the stuff inside of this me object, I need to return it by reference so that I can continue to chain this stuff along. Give me 1 second here. So they both get you to the same spot. A constructor never returns anything. That's why you don't see anything in here. But the equal operator, the copy assignment operator, does need to return something. And since you can't return this object because it's const and you've been modified, you return yourself. So if you string these things together, now you are going to be the const, and then the other object gets modified. So that is all there is to that. And so now a lot of this stuff is, you have to remember, you're using a deck under the hood. You're not maintaining any extra data because the double-ended queue maintains its size. It knows where the front of it is. It knows where the back of it is. It knows its elements. You can do whatever you need to do. You do not need to necessarily worry about, excuse me, all these details. And so I can just go ahead. Let me just set all this up since IDE do it for me. Let's just work on this, and you'll see that most of these are also 1 or 2 liners at the most, because I'm adapting a deck to pretend like it's a stack, and that's about it. Okay, so let's see. Empty. Return d.empty. I'm just delegating and say, hey, is my stack empty? Well, I don't know. That all depends on what the data is stored inside of here. Are you empty? And that returns a bool, right? d.empty returns a bool, which gets returned back. So that's all there is to that. Let's worry about push and pop in a second here. And in, I'm going to return d.size. How about that? That's it. I don't know my size, but I know that because I'm not maintaining my own data. This is maintaining the data. So then, yeah, we'll do push, pop, and top last here. And then when it comes to swap, I can use the swap algorithm that comes with, I believe it's in the algorithm. For some reason I don't have to touch it here, but that's okay. And all I'm doing is I'm swapping the contents of my double-ended queue and the double-ended queue inside of the other object. And that's it. And so it might just be pointer because they're references, because the swap is always referenced. You can see, you can't see me pointing, but you can see inside there the little ampersands that are screaming out that these things are taking references so they can modify, because you're swapping the data inside of it. So that's all there is to this stuff. And now with push, pop, and top, the only tricky part is remembering, first in, first out, last in, last out, last in, first out, whatever. There's 4 different ways to do this kind of stuff, and to make sure that we're implementing a stack the way that we're supposed to. Since this thing is a double-ended queue, we can pick and choose which side we want to use for what. And I just would say, since this is a stack, I'll use the back of the double-ended queue. So if I was setting up a queue, I would set the front would be the head of the line, and then the back would be the back of the line. And so the back will always be what I use here. So if I do a push, all I want to do to my double-ended queue is I'm going to do just a pushback. Okay, and so that's all there is to that. And we have to say, the more you work with this kind of stuff, the more you learn the little ins and outs, the little details. And when it comes to like this top, it just returns a double. It doesn't return a pointer. It doesn't return a reference. It doesn't remove. It doesn't pop. It just returns whatever is in, like however you want, the begin iterator. Let me see if I can star this. And so, basically get me the first element that, which comes back as an iterator, dereference it to get me the exact double. You could also do something, I guess you could also do something like this. Return D0. Because that's the first element, whatever it is, or I'm sorry, oh geez. Has to be I'm using the back. Oh my God, I got to use the back. So I have to use something like, let's see what I have to do. Just getting squeaky here. Just getting Getting back into it here. So what I want to do, since I'm pushing to the back, and I'm pushing to the back and pushing to the back and pushing to the back, I want to make sure that when I say what is the top element, that it is the back element, and see that it returns a double reference. So it does return a reference to the last element inside of my double-ended queue. And so also what I can do here, when I go to pop, I can just do a pop back. And one thing, again, coming back to this, that there is no, you don't have to put in any throw catch or try catch or anything like that, or just throw exceptions when things go wrong, because when you read up in the documentation, especially in the Jasudas book, it basically tells you that it just blindly does it, and it's up to you on your end to presume that there is a top. Because what happens if I try this without there being anything here? Let me see. We can play around with this briefly here. Not to the extent you guys did it for your homework assignment, but for me, if I can say stack A and then I say A.pop and run this, what will happen? There I go. I have a debug assertion failed because my deck was empty before the pop. And so, again, you could put something in here. That's if you're writing this code and you're writing the documentation and you're writing the library, you are fully within your right to do whatever you want. Just be like, okay, I'll throw an exception. But an exception's already getting thrown, so why would you throw an exception on top of the exception that already is being thrown? So that's the nice part about this, is that it's not up to you necessarily to always worry about every little detail. But I think that covers the stack, because the only parts of the stack that makes it a stack is the push, pop, and top. And again, if we're all in, since stack is last in, first out, so whatever's at the top of that stack is the thing I'm going to be tinkering with. So I push, 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 and then I can pop back, and then my top element will always be whatever's at the back. So that pretty much covers stack. So let's now take a look at doing the same kind of thing, and and replacing everything and making it a queue instead of a stack. It's very similar, and we'll see in a second here. All right, so moving on over to queues. I did the same stuff where now it magically kind of worked where I could move stuff around. So I have a queue class. So a queue class is first in, first out. Basically, a queue is a line, right? You go to Great America, or you go to wherever, you stand in line, you're at the supermarket, you're standing in line, you're the first one in line, you get served first. And if you're the fifth one in line, you get served fifth. And everything kind of goes in as such, first in, first out. And so it's a little different than the stack, but you'll see a lot of this is the same. So I have my default constructor, my copy constructor, my copy assignment operator. This time around, because I'm using both ends, the stack was just using the top and the top only. But now the front and the back matter. The front is the next thing I'm going to process, and the back is where I put things into, basically put things in line. So I have an empty function, a pop, and a push, just like before, and I have a size and a swap. So we can do a lot of this stuff the same way. So I can say my default constructor just sets up D. Same with this guy, where the D just becomes RHS.D. You're just copying data from point A to point B. The same thing goes here, where my D is equal to the other D. And then I return star this. Let's see, back and front will take care of empty. The same deal goes. I'm just going to return is D empty. And when it comes to push and pop, we'll wait on that too. Size is the same thing. And I will return D.size. Fair enough, right? And then the last one here is the swap. Same thing goes. I'm just going to use the standard swap and just say swap my D with the right-hand size D, and everybody's happy. And so that takes care of the majority of the work here. Now all we have to do is to deal with the actual pushes and pops and what to do with where does the data go. And I was describing earlier that we're going to remove stuff from the front and we're going to put stuff into the back. So when I go to push into my double-ended queue, I am going to push this thing into the back end. And when I pop this thing off, I'm going to pop from the front end. And it feels weird. Oops. Yep, I'm just popping from the front. And it feels weird. I got the back and the front, and they could be the same item. If there's only a size of 1, the front is the same item as the back. But for anything larger than 1, as you can imagine, that you have, it'll take care of things. And again, it is not our job to worry about what happens if there is nothing to pop. It'll throw an exception in, just like the standard library would anyway, so you don't have to do anything on your end necessarily to take care of that. And so that's all there is to that kind of detail. Push information into the back, pop information into the, pop it from the front. And now when it comes to everything else, you can just use, like in this case, what is the front element? Just give me, just return it. Because the front returns a double reference. And then the back will return a double reference. And that's all there is to it. And since this is a queue, you probably don't need the back. But I have it in here just because I guess it doesn't hurt to just play around with it a little bit. But if you're thinking about a queue, you're only looking at the next element in line. You're not necessarily looking at everything else. So like ultimately, this is probably extra behavior that a queue generally doesn't have. So I guess I could get rid of that. But I definitely need the front, and I definitely need a push and a pop. I push from the front, I can get the front element, I can pop it off, and then I can put new elements onto the back. But that covers the entire lecture or the entire homework assignment that I wanted to cover. So as always, if you have questions or concerns or anything at all, you can get a hold of me at swardb@cod.edu, or you can absolutely get a hold of me here on YouTube. Comment below. I'll get back to you as soon as I can. As always, thanks for sticking it out with me, guys. And thanks. I'll see you next time.